Please. Okay. So name one way that a cluster sample is the same as a stratified random sample. Yes.
Like you don't break down the population.
Okay, you split into groups. Good. So population, why is that so massive? Ooh, no. No. Like what is going on? Population, that's little. Split into groups. And they're random. Okay. Wow, this looks horrible. Okay. Okay, we're going to the iPad next week. Okay. On B, name one way that a cluster sample is different from a stratified random sample. Cluster are heterogeneous. Okay. And stratified is what? Homogeneous or homogeneous, however you want to say it. Okay. Anything else? Okay. So cluster looks at individual. While stratified looks at a simple random sample from each group. Yep, we're writing on the side. Okay. Number 2, at a certain high school, Lord have mercy. Okay. A certain high school, every student is required to take an English class each year. English, not, okay, whatever. And they are required to take physical education class each year. How many of y'all are in a PE class right now? Raise your hand. Like some type of PE. Exactly. That's my point. Okay, whatever. The high school counselors want to use a cluster sample to estimate the proportion of students who have their driver's license. Okay, should the counselor use English classes or the physical education classes as the cluster? Why? It has more like juniors, seniors, right? Because like if we look at the English classes, we automatically get rid of the 9th and the 10th grade, right? They can't drive. Well, not the legally, not the legally. Oh no, that scares me. That really does. Okay, so PE classes because multiple grades are represented in the class, and they're more likely to have a driver's license than freshmen and sophomores. Now, you could have a 16-year-old freshman. That is a possibility. All right. What is one advantage of using a cluster sample compared to a simple random sample? I heard words. More convenient. So data is easy to get and efficient too. Efficiently. Yep, this keeps getting worse. Okay. So the counselor will only have to go to a few selected rooms rather than having to go to many rooms and find all the students selected by a simple random sample. All right. 3 is probably a tricky question because you're actually having to describe the method. This is going to come back to kind of haunt you just a little bit. Each Major League Baseball team is allowed to have 26 players on the roster. 30 MLB teams. This means that there are 780 players on the opening day rosters. An avid baseball fan wants to select a random sample of these players. Okay, so we're going to describe a simple random sample of 100 players. The first thing that we're going to do is we're going to say label the players from 1 to 780. Okay, so remember, we always have to identify who we're labeling. Then we're going to use a random number generator, okay, to generate 100 numbers with no repeats. And then select the players that correspond. We okay on that? Okay, on the next one, describe a method that can be used for a stratified random sample. Okay, of 90 players. So what we're going to do is we're going to take our 26 players, we're going to label for one team 1 to 26. And then we're going to use a random number generator to generate 3 numbers between 1 to 26. No repeats. And then select the player that corresponds. And you're going to repeat that process for all 30 teams. Okay, so you'll go on your roster, 1 to 26. Select 3 numbers. You'll pull those 3 players, and then you'll do that for the 30 other teams. Yeah. Yeah. So 30 times 3, that would give us 90 players. Yep.
In the first part, you can do the lottery system as well.
Like, what do you mean? Like putting all of their names in a hat and yeah, you can do it that way. Okay, now describe a method that can be used to select a cluster sample of, I can't see that number anymore, 78 players. Okay, so you're going to label each team with a unique number. So label teams with number from 1 to 30. You're going to use a random number generator to generate 3 numbers between 1 and 30. Because you got 30 teams. Yeah. And then select every player for each team that corresponds to number. That's going to give you like 90 though, right?
Combined like 3 teams together and then make a template.
Yeah.
Mm-hmm.
But no, you were saying take the 780 players and do what?
Oh, break it down between groups, so that way one they don't have to be 70 group.
We got to cluster them based off of what?
I would do this combining 3 teams, so then it's still one group, but it's just doing the varies.
You got to have a reason for combining them,
I guess area.
like by like regions or whatever. Okay.
Separate everything depending on the regions.
I think you could do that too. There's a couple ways you could do cluster sampling. You could do like maybe years with Major League, like group them, but they just have to be broken down evenly. And then describe a method that can be used to select a systematic random sample of 78 players. I like this whole like 78 number. All right, so you're going to label each player from 1 to 780. And then you're going to use a random number generator. So this is what you were describing, Nova. Use a random number generator to generate one number between 1 and 10. The player that corresponds to the first, to this number is the first player selected. I'm writing it down here. To the And then you're going to select the 10th player after. So you'll pick a number, start with that person, and then you'll count 10 over until you get 78. Yeah, 78 players. So you'll repeat that process over and over again. Whenever you see the word systematic, you're going to go every 10th player or every 8th player. So you'll pick a number and then you'll continue that process. Okay. All right, number 4, Zillow wants to estimate the average value for houses in Chicago, which has 178 official neighborhoods. To do this, they will select a random sample of houses in the city and then send an inspector to each house to find its value. Give everybody a second. Everybody's trying to catch up on this. Okay, so option 1, select a random sample of 5 homes from each of the neighborhoods. Option 2, select a random sample of 5 neighborhoods and visit every house in the selected neighborhood. Name the sampling method used in option 1. Give one advantage of using the sampling method. So what is that? Yes. And what's one advantage of it? Reps the neighborhoods, right? How do we know that this was stratified and not I don't know, something else? Okay, so if we would have gone into the neighborhood and said, hey, we're going to sample all of these houses, that would have been cluster. Yeah. Okay. Option 2, select a random sample of 5 neighborhoods and visit every house in the selected. So what is that called? Cluster sampling. Okay. And why is this a good thing? Easy and convenient. Which method is more likely to produce better estimates for the true average house in Chicago? Stratified, right? Okay, and that's because it gives a better representation of all of the different neighborhoods, not just one neighborhood. Okay. We okay on that one? Okay. Go ahead and take out your notes. Let's go ahead and knock those out because it's not super long. And then I want to go back and hit some statistically significant kinds of questions. You want to go over 5? I really don't want to draw these things out. Okay, so the Gallup, we're going to briefly talk about this one. Gallup organization conducts surveys to find out public opinion. Often use complex methods to select their samples. Suppose they are considering 4 different sampling methods for estimating the president's job approval rating. For each of the following sample methods, create a dot plot, which represents the estimates from 10 simulated samples. Suppose that the actual job approval rating of the president is 45%. So a method with low bias and low variability, whenever you draw it, okay, it would be right around 45. So you would have all your dots. And this is 10 times, you're going to have 10 dots. That's 9. And 10. This is low bias and low variability. So everything is just kind of like together. Okay. Low bias and high variability is going to be everything's kind of spread out, but it's around that 45. Okay, so it's going to be somewhere in here. So it's spread out, but it's kind of centered towards that 45. Okay, so this is B. This is A. High bias and low variability. High bias means that it's going to be um, like farther down from that average that they give us, right? So they told us 45 here. Okay, so when we draw our thing, here's 45, and we want low variability, so we want everything grouped together. So it's going to be down here, let's say like at like 40. Everything's grouped down here. Again, make sure that you got 10 dots. I think I missed a couple over here, but that's okay. With a high bias. So high bias means that the percentage is going to be greater than what actually happened when we did our simulation. Does that make sense? Okay. And then on the last one, high bias and high variability, similar to this one, but it's going to be more spread out. So it's going to be roughly around here, but it's going to be more spread out. And you don't want to kind of get near that 45. We want to be away from that. Got it? Okay, and these dot plots don't have to be perfect right now. Okay, so go ahead and make sure that you have your packet out. I'm going to give you this little sheet. There's only 15. You're going to work with a partner, and you're going to determine the conclusions for each one of those questions on your paper. So you should be on the page that says, does SAT prep improve scores part 2? And so we're going to do the little card sort. No, I didn't cut them out. They're not cute, but that's okay. So you need 2 between 2 people. I'm sorry, you need 1 between 2 people. Okay, so share with your neighbor or share with the person behind you. Okay, so you're sharing with the person or around you. Make sure that they can see. Okay. Okay, so ready? Some students at your school claim that taking an SAT prep course will help them improve their SAT score. Design a study to help discover if the claim is true. Here are 6 proposed studies for investigating. Suppose we found the mean SAT score of students who took the SAT prep course is significantly higher than the mean of the SAT score of students who didn't take an SAT prep score. What conclusions could be made? So number 1, when you read these, you got to read it slow. Okay, you can't like skim through it really quickly. Get all students in a senior only first hour class to participate in a study. Ask them whether they took an SAT prep course and divide them into 2 groups based on their answer to this question. What was the conclusion? So you said what? Did it say C? Okay, and that is correct actually. So C, why did you pick C? So there's an association. You cannot conclude like one did not cause the other because you're observing what happened. Does that make sense? Okay, so if I were you, I would say there is an association between SAT prep course and higher SAT scores. 4 students in this class. Now, we can't necessarily say it for everybody, but for students in that class, this is what was the conclusion. We okay? Now, was that a random sample? No. Okay, on number 2, select a random sample of seniors from your school to participate in a study and ask them whether or not they took an SAT prep course and divide them into groups based on their answers to this question. So what conclusion could you make? Why? Mm-hmm.
And then, they also,
They're just observing what happened, right? Okay, so for all seniors at the school, there is an association between SAT prep and higher test scores. So just like the last one. The only difference is now we're looking at all of the seniors and not just one class. Okay, now is this random? What did they say? Yeah. Yeah. Mm-hmm. All right, number 3, select a random sample of students who have taken the SAT from your school to participate in the study. Ask them whether or not they took a prep course and divide them into groups based on their answer to this question. So are we still observing? Yes, so we're going to look for the one that says there's an association. A. Okay, so for all the students at your school, can I scroll down? Yep. Okay. So you're going to say for A, and you're going to say for all students who have taken SAT at your school, there's an association between higher SAT scores and taking the prep course. Is this random? Yes. Oh, too many. This has a random sample. Okay, random sample. Okay, number 4. Get all the students in a senior-only first-hour class to participate in a study. Randomly assign half of the students to take an SAT prep and have the remaining half not take an SAT prep. Then both have the SAT again. D, why?
Because you're getting all the students into the class, and then, let's see, you're also conducting a study. There's like, concrete results.
Okay, so for students in this class, taking an SAT prep course caused higher test scores. Good. Now, is this a random sample?
Mhm.
Why?
Because you can see them.
Okay. All right, number 5, select a random sample of seniors from your school to participate in a study. Randomly assign half of the students to take an SAT prep course and have the remaining half not take an SAT prep course. Then both take the SAT again. Which one is this? F. Why?
Because you're in all of this, yes, at the school. It also is like coffee.
Okay. And then same thing as the last one, taking an SAT prep course cause higher test. Okay. Y'all know what those little quotes are, right? It's like, look at what the previous thing is, quote it. All right. And the last one, select a random sample of students who have taken the SAT from your school to participate in a study. Randomly assign half of the students to take an SAT prep course and half not take an SAT prep, then have both of the SAT take the SAT again. So, oh, is the last one a random sample? Is number 5 random sample? Sorry. Yeah. And then number 6, is that a random sample? Okay. And the only one that we have left is B for that one. So for all students who have taken the SAT at your school, taking an SAT prep course causes higher SAT scores. So notice how the conclusion has to state who we're talking about and if it's an association or if it's a cause. Okay, so when you make a conclusion, you have to say who you're talking about and what happened. Okay. All right, so 6 was B. Okay, really quick, let's talk about random assignment. So on the other side of all of these questions, don't flip the page yet. Coming back through this. Go back through this. At number 1, was this a random assignment? Was it a random assignment? No, it doesn't say randomly assigned to these groups. Okay. Number 2, was it a random assignment? It's a random sample, not random assignment. Okay. What about 3? Okay. What about 4? Yes, it says randomly assigned. So notice how on 4, that's where we start seeing a cause. If we say randomly assign people to groups, now we can say cause. Do you see it? Okay. All right. And number 5, is it a random assignment? Yes. Number 6 is a random assignment? Yes. Okay. All right, good. All right, go ahead and flip that page. Let's kind of summarize it. Okay, so what we do is we take a population. Yeah. And then we get a sample, right? We do like a little snapshot of what's going on with the population, right? So a random sample allows us to generalize our conclusions to population from which we sampled. Okay, so that is where we said for all the people in this class, for all the people in this school, that's talking about the population. The sample is how many people we took, right? Because we didn't like sample everybody in that population, right? Well, except for that first one. That first one, we didn't do a random sample. All right, now we just talked about the fact that a random assignment allows us to conclude a treatment causes change. Okay, so what we did in the last one was we had like 30 students. And then we did a random assignment. And then we broke them into two different groups, group 1 and group 2. You have to read in this unit. Gotta read. Hmm? Did I correct something? Oh, maybe. I think I cracked my elbow. I don't know. When you hit 30, it's just different. It's just different. All right. Go ahead and try 1 through 5. We're gonna try 1 through 5. All right. So Zach works at Verizon and wonders if iPhones last longer if the screen's brightness is set to low. That's a dumb question, but all right. He selects a random sample of 20 brand new iPhones from this store and randomly splits them into 2 groups of 10. For the first group of 10 iPhones, he sets the screen brightness to low and then starts a movie. For the second group of 10 iPhones, he sets the screen brightness to high and then starts a movie. For each iPhone, he measures the amount of time until the battery is all the way dead. He finds that the low brightness iPhone lasts longer on average than the high brightness iPhones. Still a dumb experiment. All right. So is this an observational study or an experiment? Okay, why? Be careful saying that he conducted a study. Like, you want to make sure that you have a what? Controlled variable. You got treatments, you have random assignment, right?
Like, I know it sounds bad. You know what I mean?
Yes, I do. I get what you mean, but remember when you write that out, you got to be real particular, just like in your 250-word essay. I'm just kidding.
Yeah.
All right, so random assignments to treatments. Okay, remember, experiment means that we can say there was causation that happened. You have to talk about random assignment to groups. Okay, was the explanatory variable and the response variable? What was the explanatory variable? Screen brightness. And the response was battery life. I feel like this is the dumbest experiment, but yes. Was a random sample used to collect the data? So did we use a random sample? Yes. Was there a random assignment? Everybody okay on this so far? Not too bad? All right, what conclusion can we make from this study? Okay, so what are we gonna say? What was our population? Okay. For all iPhones, what are we talking about for all iPhones ever? Okay, so we're talking about all iPhones from this store. Has to be specific because we can't say about every iPhone and forever all meant, right? A low screen brightness causes what to happen? Increase battery life. But yes. Okay, you have to state who and whether it was a cause or an association. Yes, ma'am.
You can like do the opposite with that. Like you can say higher brightness causes the going to that.
Look back at what the actual question was saying. He was trying to see what. Wonders if iPhones last longer if the screen brightness is set to low. So you want to talk about that context.
That's what the screen brightness so you'll limit the battery lasts longer and have
That's okay. Okay. We good?
Yeah.
Recommended assignments. You need to knock them out. if you are trying to do your retakes, you need to finish your workbook. So if you're behind on stuff, get your life together tonight. Okay. We're going to do a quiz tomorrow. Okay. We're going to do a quiz tomorrow because we need to get a little bit of practice in this. Okay. It's going to be over the sampling type. It's going to be over this stuff like drawing a conclusion. Drawing an outline on an experimental design, and being able to tell whether it was an observational study and experiment. Okay. So tonight you probably want to do some practice with it. Okay. If you're done with your recommended assignments, I suggest that you do that 4.5 that I gave you today just to get a little bit more practice. Can't hurt to do more practice.